Okay, if you remember, we started this chapter 4 by calling it applications for derivative. And we spent some times discussing 4.1 up to 4.5, how to use derivatives to sketch the graph of a given function. In between, we discussed the maximum and minimum values, local values, extreme values, etc. Now, today we have another application for derivative called optimization problems. In real life, we face many problems called mini-max problems, minimizing and maximizing problems. Sometimes we are looking to maximize. For example, we can always ask a person to choose, for example, a piece of land with a certain parameter. So his target will be to get the maximum area possible. So he need to maximize the area. Or you have a volume, you need to construct certain, uh, shape, and you need to maximize the volume. Or if you are looking for money, for example, in economy, you always try to maximize the profits. Sometimes the other way around, we face problems that we need to minimize. For example, I'm looking to move from one place to another. So I will always look for the shortest distance that will minimize the time for me. So minimizing the distance is important. Sometimes we need to minimize the time. Or in economy, for example, we need to minimize the cost. For example, if I construct certain types of oil can, for example, then my target would be how to minimize the cost in forming such a shape with a certain, of course, properties. So these kind of questions called optimization. What is the optimal solution? Optimal means the best solution. What is the optimal solution? Even in medicine, sometimes we have optimization problems. يعني if someone, for example, suffering from epilepsy, اللي هو الصرع يعني, so he should take a medicine, and that medicine should be in a certain level. What is the optimal dose for this patient? This is very important because if you increase the medicine, it will be a problem. If you decrease it, it will be a problem. So, what is the optimal? What is the optimal dose for each patient? It's different from one to another. Anyhow, today we'll treat such type of problems called optimization problems. In this section, we are discussing only one-dimensional optimization problems. That is a problem depending on one variable only. Otherwise, we may have several variables optimization problems. Okay, we may have several variables optimization problems. Inshallah, that will be discussed in 201, Math 201. Okay, how to solve in general an optimization problem. If you remember in 3.9, we talk about related rates, word problems. So always, if you have a word problem, maybe the challenging part is to convert it into what? Into mathematical equation or mathematical model. So modeling the question, reading the question, convert it from words to mathematics. After we convert it to mathematics, we will use the idea of 4.1 up to 4.3 to find maximums and minimum values depending on the question. So here are some hints or some, let us say, some guidelines to solve what we call optimization problems. What are they? The first one says, try to, let me just move a little bit here and then come back, okay? Because the OneNote is not responding. Now it is okay. The first guideline says you need to understand the problem. Of course, when you read a question, you need to understand it carefully. What do you mean by understanding the problem? We mean by that you need to look for the quantity that need to be maximized and need to be minimized. So we need to look what is the unknown, okay? What are the given quantities? What are the given conditions? If you are talking, for example, about the dimensions of a rectangle, then you need to write that the length should be greater than equal to 0. And also the width and the length, both of them should be greater than equal to 0. So there are some conditions there. Then it is better, especially if it is a geometry problem, to sketch a diagram to imagine the problem. The third one, as we did in 3.9, we will introduce some notations for the variables. Number 4, I will look for the quantity that will be maximize or minimize. For example, here we call it Q for quantity. If it is an area, I will call it A. If it is length, I will call it L, and so on. If it is a height, I will call it H, depending on the problem. The quantity that will be maximized and minimized, I will find a formula for it. After that, number 5 and number 6. Number 5 says if you have more than one variable, as you did also in 3.9, you take rid of one of them and write it only in terms of a single variable. And finally, you need to use the idea of 4.1 up to 4.3 to find maximum and minimum. The best way to understand this section is to solve exercises. I will try my best to solve as much as I can from variety of questions, ideas about maximizing or minimizing a certain quantity. I will start with very simple exercise here. The question here, let us read it together to apply these strategies. It says, find the dimensions of a rectangle. So this statement means we need to find the length and the width, okay? With parameter 100 meter, whose area is as large as possible. Assume someone gave you like a rope of 100 meter, and he said, okay, this is the land, go ahead and circulate a certain rectangular land for yourself to build a house, for example. At that time, your target will be, what is the maximum area possible I can take? So your target will be to maximize the area of the land you need to circulate. So let us try to now convert this one into mathematics and see what is the quantity that will be maximized, how to rewrite it in terms of variables, how to take rid of one of them and make it a single variable equation, then how to find the maximum and minimum needed about the question here. مثلا, and we will find dimensions of rectangles. So simply what I will do to imagine the problem, I will sketch a rectangle here. I will sketch a rectangle. Let us say this is a rectangle. Okay, sorry for this, but need to be straight line anyhow. I will call the width maybe equal to x and the width is equal to y. يعني one of them is x, the other one is equal to what? Is equal to y. Now what I need to do, he said, whose area is as large as possible. I chose some questions from the book, some questions, examples from the book, and some questions are old exam problems. So we have combination now. In the first one here, this is a question from the book, exactly here. When you see the question without example, it means this is a question from the book. What is needed here? What is needed to be maximized? What is needed to be maximized is the area. I need to maximize this area enclosed by this rectangle. So the first step will be, can we find a formula for the area? What is the area of, this is the area problem. So what is the area of a rectangle? And the answer will be x times y. X times y. Of course, here x is positive and y is positive. X and y are greater than 0. جيد. الآن السؤال, what is the relationship between x and y? He said, dimension of a rectangle with parameter 100. What is the parameter of a rectangle? Of course, it is, as you know from Math 001, it is 2x plus y. Twice x plus twice y. This is given in the question to be equal to what? 100. You agree with this? Any question before I go to solve the question? I mean, to continue the solution of this question. If you have any question up to now, we have an area that is x times y, given in the question that 2x plus y is equal to 100. I need now to rewrite the area in terms of one variable, and that's what exactly I will do. لاحظوا من المعادلة الثانية هذه, this implies x plus y is equal to what? Is equal to 50, isn't it? And this implies y equal to how much? 50 minus x. Minus x. طبعا I will write here x and y are greater than 0. ممكن نقول greater than or equal to 0. It's okay, no problem. Now let us go and try to see how to find the maximum area. I will say now I can write the area in terms of x only. That is x times y, but y is 50 minus x. تمام? So this is equal to what now? This is equal to minus x squared, if you like, plus 50x. I'm just rewriting terms in another form. طبعا I will say here x is greater than or equal to 0. No need to repeat it, but we keep it in mind. If you need to forget about this, no problem. You can write it this way. But x here is a positive number because you are talking about dimensions, about lengths. So it should be non-negative, okay? طيب, how to find now the maximum? How to find the maximum? We go back to 4.1. I will find the derivative of this, a prime of x. Now, what is a prime of x? It is minus 2x plus 50. I need to locate the critical value. So I'll put this one equal to 0. And clearly you have x equal to 25. The question now, is this x equal to 25 really give us a maximum? I need to test it by either the first derivative test or the second derivative test. If you are using the first derivative test, okay, let me just draw this one carefully. If you use the first derivative test, then what do we have here? We have the critical number is 25. This is 25, starting from 0 here. لاحظوا this quantity a prime of x minus 2x plus 50. It will be negative after 25 and positive before 25. So the graph is always increasing before 25 and it's always decreasing after 25. تمام؟ طيب الآن what do we have at x equal to 25? We have supposed to say we have local maximum. But actually this is not a local maximum. It is what? It's a global maximum. Why it's a global maximum? Because the function is always decreasing after 25 and always increasing before 25. So this is a maximum. So a will be maximum if x equal to 25 by first derivative test. We can say x equal to 25 will lead us to the maximum area. So a will be maximum. A is maximum. The area is maximum if I will say x equal to 25, and this implies also y will be equal to 25. In other words, the rectangle will be just a square of length is equal to 25. Sometimes in the final they will ask you find the maximum area. What is the maximum area? طبعا 25 times what? Times 25. That will give me the maximum area possible with such dimensions given in the exercise. Any question before I go to solve another exercise? You have any question here? واحد يقول طيب ممكن يكون الماكسيمم تظهر عند الأطراف يعني مثلا عند الزيرو. We know that here x is always greater than equal to 0 and less than equal to 25. Or sorry, less than equal to what? Less than equal to 50, isn't it? Because x plus y is equal to 50. So x is always between 0 and 50. Why it's not appearing at 0 مثلا or at 50? من يقول لي why this is considered to be absolute maximum, not at 0, not at 50. In 4.1 we said the maximum, the absolute maximum could appear at the beginning or at the end of the interval or at the critical value. Here the critical value give me the area 25 by 25. What about x equal to 0? Actually, it will give me 0 area. Minus 0 plus 50 times 0 is 0. Also at 50, it will give me minus 50 square plus 50 square, which is equal to 0. So really, the maximum will appear at x equal to 25. هذا السؤال الأول. طيب نشوف سؤال آخر. هنا السؤال يقول find two positive numbers whose product is 100. What is given now? The product is 100. This is given in the question. بعد and whose sum is a minimum. When I say the sum, it means the sum of the two numbers we have. So we assume the numbers. So we'll say, okay, let the numbers be, let the numbers be x and y. I call them x and y. You may call them other variables, no problem. We need to translate now the word problem into mathematics. He said find two positive numbers. Okay, we assume them x and y. What is given? Whose product is 100. يعني what is given in the exercise is this. X times y is equal to 100. This is given in the exercise. We have so many numbers whose multiplication is 100. 1 by 100 is 100. 20 by 5 is 100. 25 by 4 is 100. And so on. 200 by 1 half is 100. So we have so many positive numbers whose product is 100. Radical 100 times radical 100 is 100. We have so many, infinitely many numbers whose multiplication is 100. The question is, which pair among these pairs of numbers will give me minimum sum? The sum is minimum. يعني I need to find the sum problem. So the question is the sum of these two variables. What is the sum? The sum is given to be x plus y. We need to minimize this. We need this one to be minimum. We need to find x and y such that this will be minimum. Okay, we need to minimize the sum. So I will write now s of x. S of x. What is s of x? The sum in terms of x only. So I will write here x plus y. What is y from the given here? It is 100 over what? Over x, isn't it? So what I did now, I formulate the quantity, which is called q in the directions there. I called it here s of x, the sum in terms of x. واضح? I need now to minimize this. I need to minimize it. S of x now, I wrote it in terms of a single variable x. You can write it in terms of y, no problem. You can write it y plus 100 over y. It doesn't make a difference here. طيب, this implies now to minimize it. What I need to do now is to minimize. So this will be s prime of x is given to be equal to, طبعا the derivative of x is 1. The derivative of the other one is minus 100 over x squared, as you know. I will try only to simplify this in order to locate the critical values. I have x squared here. Then I have x squared minus 100, which is x minus 10 times x plus 10. جيد. الآن what are the critical values? S prime of x, S prime of x equal to 0. من يقول لي what are the critical values here, critical numbers? X equal to what?
Plus or minus 10.
Plus or minus 10. لكن نرجع للسؤال. هو قال شنو في السؤال؟ قال find what? Two
The minimum.
positive numbers. So can we say x plus or minus 10? I will say only
No.
x equal to what? X equal to 10, because you are talking about positive numbers here. طيب, if I put x equal to 10 here, if I put x equal to 10, will it give me really a maximum? I have minus 10 and 10. If you look, just test the sign diagram of the quantity here, you will see that it will be positive here and positive here and negative here. طبعا, we start from positive numbers. Actually, we care about 0 and so on. I don't care about minus 10. What is happening after 10? X cannot be even 0. Okay, we are talking about positive numbers. So we are talking about this portion of the real line from 0 up to infinity. 0 up to 10, 10 to infinity. After 10, that quantity is positive. Before 10, it is negative. Negative means decreasing, increasing. So what happened at x equal to 10?
Minimum.
At x equal to 10, we have a minimum. Actually, this is an absolute minimum because the graph is always decreasing before 10 and always increasing after 10. So that is called absolute minimum at x equal to 10. So what are the two numbers? If x equal to 10, sorry for this. If x equal to 10, what will be the value of y also? The value of y will be what? The value of y will be equal to also 10. طيب شباب. يعني what is the sum of the two numbers? The sum of the two numbers which will be 20. يعني the number that will give me a minimum sum and the two numbers that will give me the minimum sum and the multiplication is 100. Each one of them is equal to 10. The difference between them will be 0. The sum of them will be 20 and the multiplication is equal to 100. You can play with it, find pairs of numbers. You will never find a sum less than 20. مثلا لو أخذنا 101, the sum is 101. If you take 20 and 5, it will be 25. If you take, for example, 40 and 2.5, that will give you 42.5. So we cannot find a sum less than 20 with multiplication is equal to 100. That is another exercise. If you have any question, please, you can always ask questions about these kind of points. So I will say the sum is minimum. Is prime equal to this. So the sum is minimum when x equal to 10 and y equal to 10. With the two numbers with minimum sum is x equal to 10 and y equal to 10. Yes, please. If you have question, please. Yes.
Yes, the equation that we were given, which is x times y equals 100, only to rewrite the variable in terms of one variable, right?
This is given in the question. Before
Yes.
talking about the target, it is given in the question. Two numbers, x and y. So what are the properties? What is the property of these numbers? The product is 100. So the multiplication x times y is 100. How many pairs of numbers we have? The multiplication 100. We have infinitely many. Among this family of pairs with multiplication 100, we need the pair that will give me the minimum sum. So we need to find out the sum. The sum is x plus y. So that is the quantity we need to minimize. So we concentrate in it. It has two variables, x and y. We set our target to convert it into a quantity of only single variable. So either I take y out and write it in terms of x, or I take x out and write it in terms of y. We took y out and we wrote it in terms of x and we found the answer. Is this one clear for you now?
Yes, it's clear.
Okay, good. لاحظوا, there is a very nice question that came before in a final exam, although it is a question in the book. And usually in these type of sections, you will expect questions from the book because the word problems, usually they are careful about it. And they said, okay, let us bring statements that are very similar to the book questions. This is a question that came before in a final exam. And unfortunately, many students misunderstand the question. There is a distance and there is a vertical distance. What does it mean vertical distance here? Actually, what is the meaning of the question itself? Yeah, what we mean by what is the minimum vertical distance between the two parabolas y equal to x squared plus 1 and y equal to x minus x squared. The key point in solving an optimization problem is to try to figure it out geometrically, try to understand it, try to understand what is really the problem here, then try to solve it. And that's what we will try to do together now for this exercise. Okay, let me draw a certain shape here that will help us to sketch the graph. So let me say this is my XY coordinate. So, okay, let us do something like this. Okay, let me choose a different color to illustrate this. What is the graph of x squared plus 1? It is a parabola, has a vertex at 1. Let us say this is 1. And it is going upward like this. صحيح? This is what we have. يعني, roughly speaking, sketch of the graph. This is the graph of y equal to x squared plus 1. جميل. What about the other one? X minus x squared. Y equal to x minus x squared. Let us do some calculation here. Y equal to x minus x squared. I know that, first of all, it has two zeros. At 0 and at 1. يعني if I put it equal to 0, so it will pass through these 2 points. صحيح? 0 and 1. 0, 0 and 1 and 0. So these are two intercepts of the graph. طيب, what is the graph of this? It is a parabola but opening downward. يعني لو كتبنا هذه minus x squared plus x, I can find the vertex The vertex here is equal to minus b over 2a. Minus b over 2a اللي هو minus 1 over 2a اللي هو minus 2. فراح يطلع الجواب هنا عندي 1 half, and if I substitute 1 half, what do we get? I have minus 1 half square اللي هي minus 4 plus 1 half. That will give me 1 over 4. Okay, clear? So let us say somewhere here is, somewhere here is the graph of, this is the graph somewhere here. Let us say this is, the altitude is 1/4. The parabola opening downward, so it will be coming this way, and then it will go down. Okay, this is what we have exactly for the shape of the graph. Let us say, roughly speaking, or a sketch of that. This is not accurate, but this is will give us the idea. This will give us the idea what is the meaning of the question. This is x minus x squared. لاحظوا يا شباب, we have different distances between any 2 points in the 2 graphs we have. يعني if you choose any 2 points in the graph, I can find the distance. بس هو ما قاعد يتكلم عن distance, قاعد يتكلم عن a very special type of distance. What is it? Vertical distance. شو المقصود بالvertical distance here? What is the meaning of vertical distance? It means if you take a two set of points here, if you take two sets of points, مثلا if you take this point and this point, you are talking about distances of this shape. لاحظوا, vertically like this, vertically like this, vertically everywhere here, vertically here. How many distances we have? How many distances we have between the two curves? Vertically, infinitely many. Infinitely many. He is looking for the shortest distance. يعني assume we have 2 lands or 2 islands. I need to make a bridge between them. So always you are interested in finding what is the shortest distance between them. That will give you a straight path. Okay, so what will be the answer here? How to find vertical distance between 2 points? يعني بيكون عندي هنا x1 y1 وعندي هنا x2 y2. How to find the distance between them, the vertical distance between them? يعني x1 will be the same, the x coordinate will be the same, but the y coordinate is different in the 2 functions. What is the distance, the vertical distance between them? مين يقول لي what is the vertical distance? كيف أوجد طول شغلة كده زي كده? How to find it out?
Difference between y.
راح أسمي هذه y at the top وراح أسمي هذه y at the bottom. Yeah, can you answer in terms of these 2 notations here? What will be the answer? What is the distance? The distance always will be y at the top minus y at the bottom. الواي الأعلى ناقص واي الأسفل. مثلا إذا هذا الارتفاع مثلا 2 وهذا الارتفاع 5، هذا طول كم راح يصير؟ 5 minus 2 اللي هو كم يساوي يعني 3. واضحة هذه؟ طيب now I will formulate the quantity that needs to be minimized. لاحظوا الآن what is the quantity, what is the distance? Let me write it here. Distance, maybe I call it something like s of x عوضا عن الدي لأن الديريفاتيف ممكن نسميها أيضا d. It's up, not, we can call it capital D if you like. The distance between them. Okay, why not? We call it d of x. The distance in terms of x is equal to. الآن which graph is above the other one? X squared plus 1 is above x minus x squared. So y at the top minus y at the bottom will be simply x squared plus 1 ادي الواي اللي في الاعلى minus الواي اللي في الاسفل هي x minus what? x squared. جميل. Can you simplify now? What is it equal to? It will be x squared plus 1 minus x plus x squared. يعني 2x squared minus x plus 1. I will try to rewrite it now here and try to solve the question. Okay, so what is our distance in terms of x? It is, as we said,
2x squared minus x plus
1. I need to find the minimum distance. I need to find the minimum distance, so I need to find the derivative of this. d prime of x will be equal to 4x minus 1. If you make it equal to 0, this will give you x equal to 1/4. As we said, we can use the first derivative test or the second derivative test to ensure that this will give me a minimum. If, for example, you use the second derivative test, then d double prime of x will be equal to 4, and this is greater than 0. So this is the shape of concavity, and this point will give me what? Will give me a minimum. That is if you are interested to use the second derivative test. I need to make sure that x equal to 1/4 will give me really a minimum value. I can use either the second derivative test or the first derivative test. I illustrated for you how to use the second derivative test. If you use the first derivative test, then this will be 1/4, and clearly this quantity is positive after, negative before, so the function is decreasing, then increasing. So we have a maximum value at x equal to 1/4. So I need always to make sure that what we have here is really give us the target of the question. طيب يا شباب. Now x equal to 1/4. We need, he said in the question, find what? What is the minimum vertical distance? So we need to find the minimum distance. That is the x value, the x coordinate that will give me the minimum distance. So I will say d minimum is equal to, d minimum is equal to what? I will substitute only 1/4. So that will give me 2 times 1/4 squared minus 1/4 plus 1. And you can easily simplify this. 1/4 will be 1/16. 1/4 squared will be 1/16 times 2. That will be 1/8 minus 1/4 plus 1. And clearly all of them are divisible by 8, or 8 is the least common denominator. So I have here 1 minus 2 plus 8. So the final answer will be 8 minus 2 is equal to 6 plus 1. The minimum distance between them is 7/8 units. واضح? And it appears exactly at x equal to 1/4. When we go back to the diagram, it seems that at x equal to 1/4, at x equal to 1/4, يعني somewhere between, يعني let us calculate the two things. X equal to 1/4, يعني y will be equal to what? Y will be x equal to 1/4. You can calculate for the first function. The y coordinate will be 1/16 plus 1. That is x equal to 1. What is the vertex يسوي find? You remember 1/2 صحيح؟ يعني كأن هنا عند النقطة هذه 1/4 and this one. So it seems that this is the shortest distance will be found exactly at x equal to 1/4. And the value of it is just 7/8. I hope the idea of the question is clear for you and how to solve it also. Yes, any question, please? Yes.
Yes, it's clear. But I have a question. I'm starting to find a pattern. The first thing we do is draw. The second thing we do is find the relation. And the third thing is to use the first derivative test.
Ahsan, this is the pattern here. First, you need to understand what is going on, what is needed. Then you draw a diagram. Then you need to put some notations. Then you need to express the quantity, need to be maximized and minimized. Give it a name. Area A, distance D, height H, whatever you like. And then number 5, try to write this quantity in terms of a single variable. And number 6, you need to use the ideas of 4.1 up to 4.3 to locate the maximum and minimum values. واضحة النقطة هذه؟ طيب الآن we have very interesting example in the book. I sometimes choose examples from the book also because they have very nice ideas. Especially example 1 and 2 in the book. They are very interesting. And maybe example 5 also. Here, the question says a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. كأن عنده هو قطعة أرض and the river is coming. مثلا مزرعة مثلا. That is exactly on the border of the river. يقول he needs no fence along the river. يعني هذا الشكل عندي مثلا نبدأ نتخيل الآن. We have a land like this, rectangular, and there is a river here coming like this, passing through this. There is a river here. I will not sketch the whole thing, but this is exactly the shape, something like this. What we are trying to do, he said he has this kind or this amount of fencing material, and he need to enclose his land, which is a rectangular shape. But of course he don't need to put a fencing here. يعني لو جاء حرامي بالقارب ما عنده مشكلة هو. أهم حاجة يكون الثلاث الأطراف البقية على اليابسة يعني. So we don't need to fence this side here. What else? Let us read. What are the dimensions of the field that has the largest area? كأن قالوا له تعال حوط لك أرض على النهر هذا وخذ لك قطعة أرض زراعية وتملكها يعني. أنت راح تحوط فقط 3 اتجاهات ما يحتاج تحوط على النهر. So what will be his target? His target to get largest area possible. So how to calculate this? عشوائيا مثلا يحوط لا. He need to calculate and try to take a help of someone to help him finding the dimensions بحيث انه يحوط اقصى مساحه ممكنه. This is the idea of the question. Okay. Now after we understand what is going on, we need to see what is given. We need to give it some variables, and you need to look for the quantity that you need to maximize. We find a formula for it and try to take rid of one of the variables. Then we differentiate to find the answer. يلا نبدأ العملية هذه. مثلا I can call this side to be what? To be x. So of course this will be also what? X, because it is rectangular shape. هو مسموح له ياخذ فقط أرض على شكل مستطيل. And maybe we can call this one equal to what? Y. طيب مين يربط لي الثلاث الأشياء هذه مع 2400? Yes. Can you link these two variables, the two variables x and y and 2400? Yes?
2x plus y equal
أحسن. 2x plus y is equal to 2400. The fencing material is 2400, and that's exactly what we have. طيب, what is the quantity that need to be maximized? The area. I call it the area first. Area. What is it? I call it A. I define it to be A. What is it? What is the area of a rectangle?
X squared y.
x times y.
لا, it is x times y. It is x times y. طول في العرض هو هذا. طيب, this implies now the area in terms of x is equal to what? It's equal to x times, if you like, 2400 minus what? 2x. استطعنا نكتبها بدلالة الاكس فقط باستخدام المعادلة هاي 2x plus y equal to 2400. جميل جدا. يعني بمعنى آخر this is implies the area of in terms of x is equal to minus 2x squared plus 2400 times what? Times x. That is the area. Of course, x is positive here. X is positive. X is positive. بعد هو فقط positive يعني x only greater than equal to 0. No, it is also bounded. يعني هذه الكمية اللي هي 2400 minus 2x لازم يكون greater than equal to 0. صحيح؟ لأن هي تمثل قيمة الواي، فالواي أيضا positive. يعني بمعنى آخر إن 2x لازم يكون less than equal to 2400. يعني if you need to be precise. يعني x to be less than equal to what? 1000 what? 200. ف these are the two boundaries. طبعا لا ال x equal to 0 راح تعطينا maximum ولا ال x equal to 1200 will give me a maximum. ليش؟ لأن x equal to 0 تعطيني الجواب 0 وال 1200 أيضا تعطيني الجواب 0. فبمعنى آخر if you are solving an optimization problem in the exam and you get a value, that value always will serve for your purpose. محتاج تضيع وقتك وتتأكد وتجيب الدايمنشنز هذه. لكن يعني we need to be careful in very rare questions. يعني very nice question. There are nice questions. Actually, the maximum and the minimum will not appear at the critical value. It will appear at the boundary points. I will try to illustrate one question of that shape. لكن 99% في المسائل الجواب اللي يطلع هو دائما يكون هو الصحيح. على العموم, we need to find the x that will maximize this. So I need to find a prime of x. A prime of x is minus 4x plus 2,400. If I make this is equal to 0, this will give me x equal to 2,400 over 4. That is equal to 600. Tamam? X equal to 600. Really, is it really give us a maximum? We need to test it. لو استخدمنا second derivative test يطلع عندنا second derivative equal to minus 4. If the second derivative is equal to minus 4, the graph is concaving down there. يعني this value is a maximum. إذا استخدمنا الفيرست derivative test راح أكتب هنا 600 and I can observe from here the sign of x is negative. يعني after 600 negative, before it is positive. So this is increasing, then what? Decreasing. So this value is what? Maximum. I would say is A is maximum. The area is maximum if x equal to 600. So this implies the y value is equal to. The y value is equal to 2,400 minus 2x. 2,400 minus 2 times 600. That is 1,200. The answer is 1,200. واضح? So this is the x and this is the y value here. 1,200 is equal to y. يعني لو رجعنا للشكل كأنه شو لازم يعمل؟ لازم ياخذ العرض، يعني الطول يكون مش على شنو؟ مش على جانب الريفر، يعني ما يكون متصل بالريفر، يعني ما راح تكون عميقة الأرض لكن تكون فيها طول بس ما فيها عرض. يعني this one is shorter than this. Actually it is one half of it. One half of it. So he need to take y twice the value of x in order to find out the maximum area possible. أي سؤال يا شباب بالنسبة للسؤال هذا؟ Any question here please? If you have any, please. I will solve one more exercise and stop. Yes.
Can you repeat how did you get the interval?
Yeah, sure. أولا أنت موافق إن الإكس لازم يكون greater than equal to 0 لأنه ما ممكن يكون أصغر من صفر، صحيح؟ صحيح؟
صحيح.
And also y should be greater than equal to 0, isn't it?
Yes.
معناتها 2,400 minus 2x لازم تكون greater than equal to 0 لأن هذه تمثل قيمة الواي. Solve for x. Take this one to the other side and divide by 2. واضح؟
واضح. شكرا.
Okay. Any other question, please? I have just a note. يعني the dean of this CAC is continuing send us messages about the evaluation of the course. It seems up to today morning only, I guess 14 students only did the evaluation for the course. It is very important for the administration, especially in this situation, the online teaching. It's always important, even in regular semesters, but especially for the online, I think it is good to do the evaluation. So they ask us to encourage you to do it. يعني only 14 out of 43, I think is not a good percentage. يعني if we have time, it will not take more than 5 minutes from you. Evaluate the exams, evaluate the book, evaluate the instructor. Feel free, nobody will look for your name. Nobody knows who is writing. Write whatever you like about the style of the teaching of the instructor, about the exams, about the book, about anything you like about the course. If you have comments, if you have advices for me, if you have anything, there are, I think, places for writing comments, and we will see this only after publishing your grades. So nobody will know who is writing even, but we will see the comments. So I encourage you kindly to do it today if you have time. Take 5 minutes and do the evaluation of the course. Okay, I have last question for today. Inshallah, we will solve more in Thursday class. Tomorrow we have only a quiz. There is no explanation. Tomorrow we have only a quiz. And it will be 30 minutes, but the class only for a quiz. When you finish, you can leave. The example here says a cylindrical can is to be made to hold 1 liter, which is 1,000 centimeter cubed. Find the dimensions that will minimize the cost of the metal to manufacture the can. سابقا كانت علبة الزيت، يعني إذا أحد فيكم لحق، ممكن بعض الآن يعني بعض الشركات تستخدم هذه، يكون شغلة اسطوانية زي كذا. something like this. This is the shape of the oil can. Of course, if you are, I mean, owning a company, your target, because you are producing billions of cans, يعني, if you can save even a small amount of money, that would save a lot of money for you, for each can, I mean. So what is the target always? If you need to build a can or manufacture a can or design a can, the target will be how to manufacture it in such a way to give the minimum cost, So how to manufacture the can that will minimize the cost? I will try to formulate the question and then see if we can solve it today or we leave it even to the next class. لاحظوا أولا, let us try to imagine what's going on. So we have a can like this. Okay, the can of course has a top cover and a bottom cover. So we need to give it some dimensions. What are the dimensions of the can? I can call here the radius is equal to r. Okay, I can call the height is equal to h. I can call this one h and call this one, for example, r. The radius is equal to r. So these are the dimensions of what the can we need to find. Now, what are the properties? What are the properties given in the exercise? He said the volume is 1 liter, which is 1,000 centimeter cube. What is the volume of the can? It is the area of the circle times the height. So the volume actually is given to be equal to by r squared times what? Times h. I hope you remember this. It is the area of the cross section, which is a circle of radius r, which is by r squared times the height, which is equal to h. جميل. هذه معطاه في السؤال شو تساوي؟ This is given to be equal to 1,000 because 1 liter is 1,000 centimeter cubed. I can write it here. 1 liter is equal to 1,000 centimeter cubed. Okay, we are converting it into unit of distance. جميل. What is the thing that need to be minimized? The cost. طيب واحد الآن لو سألنا سؤال شلون نصنع اسطوانة يعني؟ What do you need to do? عندنا الآن ورق مقوى، شلون نصنع الاسطوانة؟ First, I need to have a rectangular piece. لازم أقطع زي كده مستطيل وأطويها صحيح؟ I need to bend it then like this. And then I need two covers. I need a cover at the top and a cover at the bottom. يعني بمعنى آخر, in order to minimize the cost, I need to minimize the material used to build this can. طيب شو الماتيريال used to build this can here? The surface area of the metal used to build it. What is the surface area? أجي أشوف والله هو هنا عندي area فوق في الأعلى. I need to minimize it. وعندي هنا area في الأسفل يعني material used to build a circle. الآن what is the surface area? I will call it a surface area of this. The surface area is equal to عندي دائرتين كل واحدة منهم باي r square يعني شنو؟ 2 باي r square. هذه شغلة. الآن اللي على الجوانب هذه اللي على الجوانب شو تساوي؟ الاريا اللي على الجانب هذه شو تساوي؟ What does it equal to? What is the area of the surrounding here?
Rectangle.
Rectangle. What are the dimensions of this rectangle? يعني الآن if we need to build it, what is the rectangle dimensions? لاحظوا يا شباب الارتفاع حق الريكتانجل واضح هو h. هذا عبارة عن h. طيب هذا شلون؟ هذا الآن كم المسافة هذه تصير؟
باي ار سكوير.
أحسن 2 باي r. مين قال الكلام هذا؟
علي الخلف.
علي ممتاز جدا. ليش 2 باي r يا علي؟
مساحة دائرة.
مش مساحة الدائرة، شنو؟
المحيط.
محيط. انت لما تفتح الاسطوانة افرض انك جبت سكينة وقطعت الاسطوانة فتحتها بيطلع لك مستطيل، شكل مستطيل، هو الارتفاع هو الطول، لكن العرض حقه شنو؟ هذه الدائرة تحولت إلى خط مستقيم، يعني طول الدائرة هذه، طول المحيط حق الدائرة هو المستقيم، هو القطعة المستقيمة، يعني مثل ما قال زميلكم الآن the circumference of the circle هو العرض، فبيكون عندي هنا 2 باي what 2 باي r Okay, let me just let me write this one carefully. This is the height is okay. The height is h. Okay, 2 by r. That is the length times the height which is h. هذا يعطيني مساحة شنو؟ مساحة اللي هو الجوانب. 2 باي ار اتش. اوكي. اصلا انت لما تشتق الفوليوم باي ار سكوير with respect to r يطلع لك المساحة اللي هو المقطع 2 باي ار اتش. اكررها هذه مرة ثانية. هذه الاتش واضحة، هو بيطلع لي مستطيل ارتفاعه هو الاتش هذا. فهدفنا نوجد المسافة هذه. شلون تساوي المسافة؟ هي في الاصل كانت دائرة، قطعناها هنا وفتحنا، لما نفتح يطلع لي قطعة مستقيمة. هذه المسافة هي نفس شنو محيط الدائرة هذه. محيط الدائرة مثل ما نعرف هو 2 باي ار، فصارت مساحة المستطيل 2 باي ار اتش. بالشكل هذا الآن استطعنا نوجد شنو the area of the surface area. لكن لاحظ الآن يا شباب أن surface area has two variables. What are they? By r and h. If you allow me, I will now just rewrite it in terms of r and stop here. It is 2 by r squared plus 2 by times r times h. شنو تساوي ال h الآن؟ هي عبارة عن 1000 divided by r squared. And if we simplify this, it will be 2 by r squared plus by with the by will cancel out. So I have 2000 over r. Okay, of course, here r is positive number. R cannot be negative. This is the surface area in terms of r. Next time, we will see how to minimize this. If we minimize the surface area, we are minimizing the cost. And really, we will observe something that is common in our life, but without giving it any attention. But it seems it has a purpose. It is the purpose here is to minimize what? To minimize the cost. Okay, that's it for today. I will stop here and then inshallah we'll continue next time. For tomorrow quiz, inshallah you'll be well prepared for it. Okay, it will be through the Blackboard. It will be through the Blackboard. I will send you the starting